So in this video, we are going to discuss about the properties of Z transform. So the first property is linearity. So this property of Z transform is analogous to the DTFT, since both are handling the discrete sequence. So the property which are applicable to the one-sided Z transform is almost same that of the two-sided sequence also. So here the linearity property which will states that the sum of the two signal which is equal to the weighted sum of the two signal is equal to the weighted sum of the individual Z transform, right? So what time Z transform of A of x1 of n plus B of x2 of n is equal to x A into x1 of z plus b into x2 of z. So the proof is a transform of A x1 of n plus b x2 of n. So you know the formula, right? So in this formula I'm going to substitute n is equal to 0 to infinity A x1. So this is from minus infinity, right? Minus infinity to infinity A x1 plus b x2 of n into z power minus n, right? So if I solve, I will get summation n is equal to minus infinity to infinity A x1 of n z power minus n plus summation n is equal to minus infinity to infinity b x2 of m z power minus n. So this I can write it as A into x1 of z plus b into x2 of z. So hence it is good. So the next property is multiplication by an exponential sequence. So here if is a transform of A power n x of n, so you will get x of A power minus 1 into z. So the proof is so what is A of n x of n, that is equal to summation n is equal to minus infinity to infinity A n x of n z power minus n. So here I can write it as n is equal to minus infinity to infinity x of n A z power minus 1 into m. Like, so I can write this one as x of this I can write it as A power minus 1 is at n minus it, right? So you have to get z power minus n, right? So z power minus n I can write it as x of z. So here I can write it as A power minus 1 into z, right? So the next one is time reversal property. So what I have to do is a transform of x of minus m, that is equal to x of z power minus 1. So the proof is a transform of x of minus n is equal to summation n is equal to minus to infinity x of minus n z power minus n. So if I take k is equal to minus n is equal to minus infinity to n is equal to plus infinity, that is your limit. If you substitute k is equal to infinity, k is equal to minus infinity. So if you substitute, I will get k is equal to minus infinity to infinity x of k e power minus e power plus k. Sorry, z power k, right? So this second write it as k is equal to minus 1 to infinity x of k z power minus 1 into minus k. So this is similar to that of x of z power minus 1. So hence it is good. So the next property is convolution. So is a transform of x of n convolution h of n, it is equal to x of z h of z. So the proof is a transform of x of n convolution of h of n, that is equal to summation n is equal to minus to infinity x of n convolution x of n z power minus m. So you know the formula for x of n convolution h of n, right? So the second right test tau is equal to minus infinity to infinity x of tau h of n minus tau, right? Z power minus m. So if I substitute u is equal to n minus tau, okay, so I get n is equal to u plus tau. Okay, so in this, if I substitute n is equal to minus infinity, so what happened to my u? U is equal to minus infinity. So in this equation, so if n is equal to infinity, u is also equal to infinity. So instead of n, I'm going to substitute the u value, that is from minus infinity to infinity. Then summation tau is equal to minus infinity to infinity x of tau h of, instead of n minus tau, I'm going to substitute u z power minus, instead of n, I'm going to substitute u plus tau. So this is equal to summation u is equal to minus infinity to infinity h of u z power minus u into n tau is equal to minus infinity to infinity x of tau z power minus tau. So this is nothing but h of z into x of z. So the next property is time expansion. So what is I am going to prove is xk of n is a transform of xk of n is equal to x of z power k. Okay, so the proof is a transform of x of k n. That is equal to summation n is equal to minus infinity to infinity. This x k of n I can write it as x of n by k. So that is a representation. Is a power minus n. So if we take u is equal to n by k and n is equal to minus infinity to infinity, right? So what is u is also equal to minus infinity to infinity if I substitute in the above equation. So what is my n? N is equal to u into k. So I substitute k. U is equal to minus infinity to infinity x of u is a power minus uk, right? So the second write it as summation of u of minus infinity to infinity x of u z power minus k z power k, right? This is z power k. Z power k of minus u. So instead of x of z, you have to write it as x of z power k. So this is about time expansion. So the next one is initial value theorem. X of 0 is equal to limit z tends to infinity x plus of z. So what is x plus of z is the formula for x plus of z is equal to summation n is equal to 0 to infinity. It is not minus infinity to infinity, because for n less than or equal to 0, x of z value is 0. So therefore x plus of z is nothing but n is equal to 0 to infinity x of n e power z power minus a. Okay. So how to prove this one? So I'm going to take a limit of z of infinity x plus of z, that is equal to, if I take the limit z is to infinity, summation n is equal to 0 to infinity x of n z power minus n. So I'm going to substitute, right, 0 here. So x of 0 into z power 0 plus x of 1 into z power minus 1 plus x of 2 to z power minus 2 up to x of infinity to z power infinity. Okay. So here I am going to substitute infinity to, so anything power 0 is 0. So this is x of 0 plus x of 1 divide by z. So here z value becomes infinity. So here x of 2 is at infinity power infinity square, like. So it will go up to x of infinity divided by infinity power minus infinity. So you will get the answer as x of 0.